Okay, so let's have a look at how the area of a triangle new formula works for this. So write your title and then find the areas of the following triangle. So we're going to do 2 easier examples, and then we're going to look at 2 slightly more difficult examples in the next video. So this is just to get used to using the formula, and then we'll look at how it can progress a little bit afterwards. So get a triangle drawn. Remember, this can be used in any triangles, it works for any triangle. Get rid of the ruler. A, B, C, and I'm going to give you this angle here. I'm going to make 68 degrees. And I'm going to give this side as 4.3 centimeters and this side as 3.7 centimeters. So we're trying to find the area. So first thing to do is to label the triangle, as is often the case. So opposite big A, opposite angle A, we want little a. Opposite big B, we want little b. And opposite big C, we want little c. In fact, I'll do them in red. It's like this. So hopefully here we can see that we've got, as I mentioned in the first video on the notes, here we have 2 lengths, and we also have the angle between those 2 lengths. So if you have this set up, yes, you can use cosine rule, but now we should be able to find the area of the triangle as well. So here, the area of the triangle, so I'm just going to draw a little triangle here as my, so enough to write it out, is a half AB sine capital C, and then we can just sub in. So we're going to get a half A, which is 3.7, B, which is 4.3, sine of the angle at C, which is 68. And then we can just stick this in our calculators. So half, or 0.5 times 3.7 times 4.3 times sine 68. And we get 7.375, etc., etc. So 7.38. Remember, it's an area, so it'll be centimeters squared, and we're doing it to 3SF. So it should be nice and straightforward. Let's move on to a second question in the same video. So if we just move down slightly, you can always go back, you can always pause the video, remember. So number 2, let's get another shape drawn, another triangle drawn. And use slightly different letters this time, just to show it doesn't matter what the letters are called, it still works in exactly the same way. So F, G, H will give you angle at F here, which is going to be 72 degrees. And the lengths on this side, 12.1 centimeters and 9.8 centimeters. So again, notice we have 2 lengths, an angle between those 2 lengths, so we can definitely use the formula for this here. Oops, let me redraw that. So let's label the triangle. So opposite big F, we'll put little f. Opposite big G, little g. And opposite big H, little h. So always labeled the same. And normally our formula is that the area of a triangle is a half AB sine C. But as long as we have 2 different lengths, here and here, and the other angle, which means the angle between them, it will work. So I can write this formula slightly differently and say that the area of this triangle that I'm looking at is going to be a half, and then the 2 lengths, so here, H and G, and then sine of the angle between them, which is capital F, this one here. And then we can just sub in and use our calculator to work out there. So a half H, which we've circled before, which is 9.8, G, which we circled before, which is 12.1, all nicely labelled, sine of the angle F, which is 72. Stick it in your calculator, so half times 9.8 times 12.1 times sine 72, 56.38, etc. And again, it's an area, so let's round it, 3SF, 8 rounds to 3 up to a 4. It's in centimetres squared, 3SF. So a nice straightforward formula to use. If you've got two lengths and the angle between them in a triangle, you can find the area very straightforward.